Good morning, everybody. Namaskar. Millennium to power millennium. Good morning to everybody. This is Engineer Suraj Singh speaking from Bharat, India on this day, March 9, 2022, Wednesday, 3:40 a.m. नमस्कार. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ. आज दिनांक मार्च 9 2022 बुधवार सुबह के 3:40 मैंने स्टार्ट किया मिलेनियल पावर मिलेनियन. यू मे आस्क मी व्हाट इज मिलेनियन एंड आई वुड से मिलेनियल इज 10 to the power 1 minus 10 to the power, it's big power millennium. This is you can say if you write thousands powers, it's can say 1003. So 1003 millennium. You can see this meaning in on your computer if you want to see. It's very important. Just I want to increase your power of millennium to power millennium, and that is good morning. So many times good morning. It's very important one to see that, because we have to learn also something in addition to engineering, and that is what I say. We say that sometimes it's important to say that. You can say actually this is when I say millennium, this is 10 to power 3003, and that's very important. You can check this on computer. 10 to power 3003,000, and this is good mornings to you, and I can say that I give you whole universe like this, equivalent to that. The video and audio signals are zero, but it happens, nothing very new with Airtel. It starts with that and still it is zero, and this may fall soon. Maybe this video falls immediately because FPS are okay, something has come back. So I say okay, fine, let's continue with this. And I would say this is file, that is you can say used for email. My representation of mail is suraj_engineer at yahoo.co.uk, and of course this is important one. I hope, I expect to get emails from my friends or from my colleagues or public. That is, if you wish to write something, I know it's difficult to write about these subjects, but questions are important. This is again I say suraj_engineer at yahoo.co.uk, and this is Chartered Engineer India, Suraj Singh, Antarashtriya Professional Abhyanta, International Professional Engineer, Civil Engineer Suraj Singh, and this is my certification of International Professional Engineer, registered in you can say role of International Professional Engineers under mandate of IPEA agreement, International Professional Engineers Agreement, and then it's my Chartered Engineers India certificate, and this is fellow certificate. Meanwhile, I close these two just to save, because I am inclined to talk about coordination, quality, and certain case. Coordination engineering, as subject and title states, this is quality coordination engineering projects works. And reliable engineers are just forwarded from behind, and it's very important to consider issue of reliable engineers, or engineers who have involved so far in certain deliveries, which we cannot simply say, but we can say part of development of our country. Development is not just new, it has been for long. Of course, degree of development might be lower or higher, but development is important. Development in all walks of life, particularly in construction, in public facilities, in private facilities, which you can say can be evaluated or can be valued as assets of our nation. These assets are important because resources are properly used. And then we talk of communication, because communication is a weakened part these days. Value has gone, but quantity is more. That's why communication has to be considered this very instrument, which is a powerful instrument. And of course, a concrete material which can never be forgotten, can never be disregarded in civil engineering works contract sector has usual safety designs construction methods. So coordination engineering, I would say, I can't define means what we have to see about this. And coordination engineering should be heart of engineering, should be mind of engineering. You may say anything. Sorry. I consider coordination is a part of our life, just like quality and coordination. We can say this is coordination, quality file, quality and coordination, and this is, you can say, I don't think I should explain every time why I am so serious about this. Seriousness is very important for everybody, and since I am an engineer and those who are professionals, they must be serious in mind, they must be serious in their concept. Seriousness means one has to find destination first, or you have to decide what's your milestone or final milestone called destiny, or you can say where you have to reach, that's your goal or object. And to reach that, you must know what's path, which path, or there may be many paths or number of paths on to go onto that route. We must follow either of them, and to which path you have to follow, on to which path you have to go. It's also you have to decide, and if you know plus and minus, you can say merits or properties of that, or you can say what problems you have to face on that route. If you can foresee them, I think it will be better to move on that path, because you know what risks are covered or involved, and we can contain those risks. Just like in safety engineering, we say risks you should see, or in works engineering, we say we should know what risks are possible in this. We can plan accordingly, and that's why we say is quality and coordination that helps. Quality doesn't mean quality of material or quality of product. Quality doesn't mean quality of one item or other item. Quality is very general word, and actually nowadays used for systems. We work how we design system for our organization, and we design system for everybody. Design some system. It may be formally written or it may not be formally written, but something prevails in mind, and that something has to be checked in automatically or by use of analysis or by use of whatever. Everybody has got plenty mind. It's up to person how you can use mind, and engineering forces us to use it, because I cannot pass engineering without using mind. That's also true. If I don't use mind, I can never become engineer. That's another point. So we should be very clear about that sense. It's question of clearance, and I can say that yes, that one every day I say, and in our country, come what may be achieved, there's no other way. We cannot avoid it. If you avoid it, we avoid ourselves. We cannot move any centimeter or millimeter. So you can say works quality cannot be compromised. There's no way, and therefore we do not intend to compromise, just in name of just in name of fragile existing quality systems. Quality system is also in our hands, not in hands of someone else. What system we decide, what we say, this is our system, this is our procedure, this is our inertia, whatever it is, our organization chart, and this is our policy of system that we have to say. Actually, what I say, reliable engineers means those engineers who can have reliable programs, reliable systems, reliable quality controls, and everywhere reliable quantity. I don't say don't have quantity. Quantity is very, very significant. We must think of good quantity, or you can say abundance of quantity that fits into optimum use, and that also you can say must be with quality. So quantity plus quality should be, you can say, considerations for a reliable engineer. And if reliable engineer, or I should say engineer is reliable, because engineer cannot do anything which is not related to work. No engineer does anything which is not related to work, and that's the important point. And system, one has to decide that can be done. I cannot design a system that doesn't have any practical angle or practical aspect. Being an engineer, if I design something imaginative, hypothetical, which I think won't be done, as this is my system, then I'm not an engineer. I cannot speak clearly. One should understand what has to be done. You can say one should be to certain extent be practical in theory aspect, and we can deliver only when we know what to deliver, we know how to deliver. Delivery is last moment, is last phase. Before this are processing or design, construction or procedures, whatever you say. That's only I can say. I'm not going to quality system can fail, but quality must remain because system is dependent on ourselves, but quality of material is a part of work. It must be taken care of. This means so no one can sleep during process of whatever item. If we sleep during process, it won't work. Even is automatic, everything is automatic. We should be open eyes and open minds. And that is where reliability is named. You cannot sleep to think or by just considering that it will work automatically, and this can cause accidents, this can cause mishappenings. Solve all our problems ourselves. Nobody else is going to solve our problem, and that's where coordination is very important part of life. Coordination engineering projects, public and engineers. It is very important to say for reliable quality engineering works deliveries, coordination engineering is a must. A professional engineering it is, and it's not for all public must have awareness. Missing coordination means missing good engineering, and this very important title. Just like we say, safety is a must. Safety is first. We usually call this slogan very common slogan. Safety is number one, which means first we have to consider safety, and then we have to say if you are safe, you can do whatever you wish, whatever you have planned. Even if you walk on the road, you have to keep yourself safe from vehicles, from some stones lying here and there, from some pits, or from whatever else, from slippery. Or you may see you have to walk safely, and you have to walk safely means you have to look after all these points. Missing coordination, and means missing good engineering. Just like we say safety first, and I say that quality first and quality must. We cannot say quality is second, just like safety is not second, quality is also first, but first safety has to be considered. Then we can say in work results, quality is first and quality is must. First and must, and quality can be first, it can be must only coordination is available. If coordination is good, if coordination is workable, if we know how to check coordination, if we can check coordination means we can make sequence, and that's meaning of coordination. And you can say if you say sequencing or serializing, successful serialization is coordination, successful sequencing is coordination, successful you can say a string of activities can be called coordination. And coordination is not you can say physical term, it is something that's a state of a mind, state of works. It cannot be separately seen, but results can say successful results means successful coordination, and unsuccessful results means unsuccessful coordination. Coordination is directly proportional to success or failure of success both. If good coordination and information is available, you can say, yeah, it's okay, fine, coordination is good. This means engineering is good. Engineering, as far as coordination is concerned, information collections are concerned, information applications are concerned, results would be plus, you can say useful, and that is called good engineering. Missing coordination means missing good engineering. It's a very important point. We should care about this. In Hindi, it's written, you can read. यदि समन्वय नहीं तो स्वच्छ अभियंत्री नहीं, संचार आवश्यक समन्वय अभियंत्री हेतु. Communication support for reliable coordination. There are so many plates I put in that, and one by one I have discussed. Sometimes I discuss this and sometimes that, doesn't matter. I'm just trying to show you certain plates here. Example, I bring them just now again for your reference. This is a school building. This is a school building. This is a school building. This was constructed in 1986-87. Its location is Amsalal, Qatar, Doha. This RCC building, this is one of my projects, you can say I care about. There are so many projects, few I have included in this file because I have information, I could gather information about that. Only I included here, otherwise if I don't have information. This also I downloaded after lot search from Google Earth. Otherwise I don't have any information on this formally except few photographs that's in my book. So that's why I tried to share and compile my file with available information. Thanks to technology that at least we can trace some of our works done. So this is one of my project. I was for construction of this project on behalf of contractor Alatia Contracting in 1986-87 for this project, and consults was Qatar Consultants Group QCG, and the department was Civil Engineering Department Ministry. And this another project. This is Iraq, Baghdad, 1982, and this is Daral Thawra Printing Complex, RCC Tower. This is RCC Tower, and these are tower for courts and stairs. And this is main. Actually, there are so many other buildings around, but this was tower portion, which I did as in charge of this project on behalf of subcontractor. That's what it says. And this is now a file which is done for representation of form work, how form work is done. For that purpose it is, and it is, you can say it's all line work worked up on a drawing file. It's drawn, and this is lift well, you can say elevator well, RCC well. Generally it is done everywhere, it's done using RCC. All these lift walls, but lift well wall, but in our country people don't do this. They do brick work or some do block work. I have no problem for that, but it's here I say lift well, that is RCC walling around, which can act as shear wall as well. So it's dual purpose. Then there's another plate. This is for ethylene plant photograph, and this is located 300 kilometers from Abu Dhabi. And this is Abu Dhabi, 300 kilometers from Abu Dhabi in Ruwais city, Ruwais industrial city. Here I worked in 2000, 2001, 2002, around for 3 years on this site on behalf of Al Jaber Energy Services, which was a part of, this was a Baruj project, Baruj 2 project, Baruj 1 I think, Baruj project. Baruj is a oil company of Qatar, of UAE, and I had a chance to work with Bechtel. Bechtel were designers for this Alliance Bechtel, and Al Jaber subcontractor for civil works. Baruj was client, and this I worked as a site engineer for a few months, and then I worked continuously for a couple of years as office engineer with miscellaneous activities. So this was also a good project for me to learn something and to work practically, not bureaucratically or administratively, but technically. A lot of experience, because it was engineering office work. It's very interesting one. Everybody cannot do that, because you have to sit in office and you have to visit sites also for required or important requirement was coordination, or you can say design coordination, works coordination, and it's very different kind of world. Designs available or not available, we have to review designs as well as we have to review what is required on site, because this is not entirely building work. This is foundations dominance and ordinary buildings dominance, but blast buildings, blast resilient buildings, blast resistant buildings, different type of momentum here. I can say I did not have free time on this project. Even on Fridays I used to go, because this is such a work you cannot expect any support from anyone, because it's in your mind. This is mind work, coordination work, documentation work. You cannot get support. You have your own system. Even if you adopt system by others, You have to think on that. That's a very important point. References are important in this. Procedures are important. Information is important. Without information, if you cannot find yourself, those who find problems on site, they have to inform you about whatever problems are there, clashes are there, and you have to refer to drawings and documents and specifics. Others cannot do immediately. It's question of concentration on information. Information through drawings or through specifications or through codes or through whatever means. Lot of that which we'll discuss later on. I'm just referring to that. Why I'm putting this is a part of coordination, very important part in such a project. In this you can say about, I still remember I personally did this. Even I did not have all information. I discovered all or earthed out information from drawings. So many supersessions and so many supersessions of drawing and so many revisions of all drawing updates, and we can say sometimes you could not know even at time of doing concrete, you got changes on drawing. And because this is a machine related project, it is ethylene plant where there are vessels, many vessels and many machines, so vibrating machines, or you can say stationary machines, ordinary buildings or blast buildings, or lot of utility works. You cannot say anything one or other, and you can say it's a kind of nothing clean, but everything has to be done. If even one part misses, the process stops. So it's very important from that viewpoint. You cannot measure quantity of work you have to do in coordination on such projects. It's not 1 day or 2 day coordination, it's a continuous one coordination. You have to not only coordination in engineering but also coordination among disciplines. And you can say disciplines means civil and structural discipline, civil and services discipline, civil and you can say external disciplines, mechanical disciplines. So many disciplines you cannot even imagine on such a facilities plant work. And you can say this is just a procedure, this is just a schematic drawing. I just downloaded this from one site, and that is, you can say here is schematic overview of ethylene plant based on steam cracking, and there's a researchgate.net, that is the one. I can say here is another drawing of a substation, just typical one substation, RC substation located in blast zone on that plant, and that's why included it is complete RCC framework, RCC complete cellar, and it's ordinary structure but important structure. And this is a substation, and that has to supply power after obtaining power from mains, lines, overhead lines, and that is to be given to this plant. And is another plate that is for firing range. This was constructed in 1987-88 in Barjan, 2nd Royal Guard Army camp in Qatar, on Dukhan Road, Doha Dukhan Road. This was RCC, baffle walls. These are baffle walls, you can see these are baffle walls. And here are gantries around, and there are subways. And this is open to sky, this portion. And this is a bullet trap, this building, main building, and here's bullet trap chamber. Yeah. And this is shooting area, and this is a firing area, and there are gantries this way. This is important one for purpose of training. And this is quite lined here. This is a blood trap chamber. I have not seen clearly. I'll show you another sketch here. And you can see this is a sketch which I drew of this approximately. This is a sketch of this. A sketch or drawing, you can say, firing range drawing. It starts from here. You can say it's main building area. It's a main building area, and it goes from here. You can see main building is here. A shooting range this way, and here is main building. It goes this way continuously from here and goes like that. It goes in here. All this way, the instructions are shown, other details are shown here. And here is firing range plan. This is firing range plan also with additional details, and you can say here some details are added. And so here's another one is showing, and that is firing range plan. It's different sketches. Here's bullet trap chamber. It's given bullet trap chamber where Sand mounds are here and some slab, roof slab. Means there is given description separately. And this is again the same plant, plant with exposed area, or you can say this is processing area. It's very important that the substations I showed you somewhere here, and so many components are here. You can see this cooling water, seawater basin. This is there are tanks for oils, others, and this is cracking area with compressors and wash water, wash water area and locomotive, etc. So many. Likewise, it goes on. This is fueled, a fuel, flare tower here, and this is water lagoon and its outfall chamber. And this was this also downloaded using Google Earth. And here is another one. Then some details are here. This is the same explosion, the same of seawater basin. This we are getting water from here. So seawater from sea. This is 84 inches, 7 feet or 2 meters. You can see more than 2 meters. Two pipes, twin pipes we used to call it. This RCC structure completely is a pump house RCC, and this then goes here after goes to all plant where it required to cool down equipment, and then it's returned for purpose of recirculation after treatment, and once it's gone it is then disposed of permanently. This is also very big water reservoir, you can say water retaining structure for which quantity of water is too high, and it was complete engineering, and we did all water tests according to BS 8007. And here is, you can say, another one. And that plate is this is a record building, very small building but very important building, because it is a part of plant facility, or you can say processing plant, which is located in Masaid, Qatar. This is out of that premises because for purpose of standby inside there may be record keeping, but outside in case something happens it should serve. And not only this, another one about 100 kilometers from here itself. And this is, so we start with RCC building completely, and you can say RCC building, and there's a lift, you can say here lift, which I actually this is lift here, and I try to show you certain form of here. And there are some, you can say here chiller units, and various other units are here, services, so you can say on roof likewise, and so many other points, and the water tank on ground, service area, electrical service and other services. There's a guardhouse here, and it's very very small. They are small or big, but question is that we have to talk of quality. I don't feel in shying that it's small or big, doesn't matter. Construction starts here in 2010. It was you can say Al-Tunsi company. Al-Tunsi, you may say that owner of this company. It's a ministry project, and it was, you can say, one for learning, but it structure had been completed before I joined. I looked after. There was a very delayed project, you can say. Of course, it was interesting. It's a hospital project, completely technical, and it is all utility based, because hospitals have a lot of utilities, many utilities, gas pipes important, and medical oxygen and this and that, and human electrical requirement, mechanical requirement, instrumentation requirement, and so much coordination requirement. And this, it's really to analyze such project and concentrate on how to do it, how not to do it. Of course, it is Saudi Arabia, but it depends on what sort of staff you have and what organization you have. I mean, can you organize your work? You cannot. It depends on that. So it was my first assignment of Saudi Arabia, Jeddah, and I liked it. And due to certain reasons, I don't know why it was delayed, and I was told that around 75 engineers have got left the site. This is actually planned site, planned view of this, you can see, and maybe it's a real one, I cannot say. It's not real one, it's planned one. Well, this is what look like, so you can see how beautiful it should be. It's not high rise yet, it's good one. So we can say that, okay. And of course I go to other one. This is LNG plant location Ras Laffan, Qatar. And these are tanks. I'm talking of this. I talked of this already. I was part of this in 1986. I know 1986. I think 96. Yes, I'm sorry, 96. These are 4 tanks constructed by TBMM consortium, and Midmac is one of them. I worked on behalf of Midmac as office engineer for 1 year for these tanks. My role was for surveys involved in this, and I also was technically responsible for beach villa project in Midmac. So I learned about this, how these tanks, what these tanks are, and that learning is of course very good because it's after all petroleum project or oil project, you can say, onshore. And this tank, people know what about LNG, and two tanks within one is external, that is RCC PSC tank, concrete, massive one, heavy work you can call it, because walls minimum 800 and diameter is more than 76 meters and height is more than 50 meters. It's very heavy for containment of LNG, and that is minus 160 degrees storage. And concrete is not for that purpose, so there's an internal tank in which is of 9% nickel. You may say nickel alloy, that is for purpose of cryogenicity, to increase cryogenic action, cryogenic property to steel. So it is inner tank, which is real tank, and outer tank is protective tank, or to take care, you can say, in case of accidents, leakage or something like that. In that case, this tank would turn. There's one here, you can see, if you see small here, this is a Sullage open reservoirs, Sullage tanks. This is then connected here, you can say, these platforms is connected at top, and these are 3 on each one, 27 by 22 meter platform at a sort of cupola level. And this is for what purpose, connect to this one here, and this have got relations to that one. And of course this is what I say, LNG tanks, LNG plant. I'm not expert on that, but I'm just giving my experience, what I had. These details we'll discuss, and also this is same plant view on the, you can see this is a view of that plant, and this is here, you can say, we have time of construction, and here's internal when it is inside work. Once RCC outside or external tank is over, this is other tank, you can say. Here we may say that is used like that, and we have to move further onto this, and we can say that yes, it is. And then we have here, this is during construction itself, as usual, we say this is the same tank. RCC stays in the construction towers, because many tower cranes are there, and I used to walk here everywhere to see at the time, and I was impressed with quality at that time. In 96, you can say it is 26 years back. So at that time it was good. I was impressive quality in that. And this is that plant administration area, here administrative warehouse area as well. Very ordinary structure, this building RCC, and this building is also RCC. All these buildings are RCC, and these are structures. RCC, of course, this is steel building because it's a warehouse. And then we have, this is very important. I'm showing to you. This is an example of coordination, you can say. Real coordination or engineering coordination, you can name it. It's a very important point. Actually, I still remember that time when I was on this project, and I was busy. I tried to remain busy on such works. You may ask me why I'm telling that. Yes, I'm telling because there was no such details available, and I used to find big problems there for purpose of coordination and engineering arrangements. So, of course, and this is on just one part. I actually worked on this as well as complete plant like this for purpose of just to how to do it, how to understand it, and if you can say maybe you're not able to see on this, but if you think I can show you another of this so that you can understand better. This is actually administration area, though it's landscape drawing, that's okay. But what I want to say, this is administration building here, this is amenities building, this is mass prayer building, and this is the area where you can say warehouse, etc. And this is other structures, and here is you can say here is uh, certain firefighting area, and it is something different, which you can say here that this is I just blown up. So it's affluent, it is here. You can say it's not clear, so that's blow up more. It can't be clear. It's fire station, and this is disposal of waste here, and you can say maintenance warehouse. This is amenities, and this is mass. Likewise, you can say I'm not going. And here is the consumer estate gatehouse. Sorry, this gatehouse, and this is open parking, chiller, enclosed area for this building, chiller enclosed, access to this building, and this is pathway, etc. And this is generally used to call administrative area. Now you may be able to see why I took it for purpose of roads, internal streets, and these are roads. You can say these are roads coming here like this. Elsewhere, we had to work on landscape, actual landscape and road. I had to just set out exact information for purpose of shop drawing for roads, shop drawing for landscape, though it's not structural one, but it has to be done accurately. And landscape, you can say we did a lot of work on this. I involved personally. I had no input from someone else, no support, but I did a lot work on this complete plant itself, and big drawing was posted. Actually, that should be given by designer, but designer had made many pieces. Designer published, or you can say produced many pieces of various parts of this, but I put like this everywhere, and I successfully did this. It helped me itself because I had to coordinate with various problems, and we had to produce landscape plan, landscape details, which could not be possible otherwise. Still, I feel happy to see this again, though I did this myself, and it took a lot of time, and people could not understand what I was doing. So I'm not a layout planner. Yet it doesn't matter what you are. It depends on your concentration. Mind is so much in engineering. Once you pass engineering and work in engineering field, there's no question of discipline. There remains no question of discipline, but how you do. And if you don't believe, I think I used coins of half rupee, or in that case they are in reals. I use this using not arc, but you can say you can use arc also, doesn't matter, but depends on. And still I think nowadays it's automatism, and you can find various softwares. That time I used only AutoCAD only for this purpose. I was very fresh in that time. I was just learning software. AutoCAD I learned myself for this purpose. And it helped a lot, I can say. It helped a lot when drawings were submitted for landscape, levels, etc. Like this is also a part of submission. It's a part of submission, and it gave me a kind of satisfaction that what is engineering, what is coordination, lot of various drawings, and based on this I also did some changes which were agreed as red lines record and then converted to as-built records. Same way I did many more. I just try to give you this because your reference. It's not that I can explain everything. That's not my objective today. My objective is just to let you know what does coordination mean. And then it's landscape plan. Same area as landscape, the green all here. Green air. There are two kinds of landscapes everywhere. One is soft landscape and other is hard landscape. For example, this is a part of hard landscape. These cobblestones and these streets are all part of hard landscape. There's green and irrigation here, irrigation network of plants or whatever else is soft landscape. And of course, this down for purpose of this we have to do it. And here may say that. Then we go to, it is some, I just broke down so you can see clearly. Now this is again, you can say, cracking furnace, a part of that alien plant. Very much structural work with RCC foundations only. And you can see so many piping equipment and all that, which I do not know what these are, but for purpose of foundations we have to deal with all. And same, this is, you can say, another structure, steel structure with RCC foundations, and all mechanized work. And now this is RCC building, a residential building, and we can see a kind of framework. These frames, these frames, this is basement, cellar, and this is RCC beam with columns here, beams and columns, which were worked out based on Ganesh rotation contribution method, not finite element, and it was done. You may say that if you can see plans of that, you can find something interesting here, because interesting means something useful. I'm feeling a little cold. I don't know if temperature falls. Let me check it is how much. It's 16, it's still 16. I'm feeling cold. There's no reason for that because of this dew point is 8, and that's the reason is the 8 dew point now. So I had to be sickly oriented with this, and I just wear my protective clothing because I can't tolerate cold. So we can say very well that okay, fine. It's now time to. Now these plans, this I'm showing to you, are important from engineering point of view. These are detailed engineering plans. Only few I am showing. There are many from professional viewpoint, but I am showing always strictly here. This is one plan on ground level, and here are some elevations here that put in that way so that it was easy to draw, because I didn't know 2D, not 3D. I'm not very much good in 3D. I don't know what's 3D, but I don't practice AutoCAD for long years, many years. And this is certain section. It's also certain section. And here is stair. Means something, and you cannot say exactly what it is, but this is main stair. Actually, that is something else. It's main stair, and you can say it's inclined, or you can say pitch. This is stair cover, and here is second floor. This is basement. It starts from basement, it goes to basement area, then ground floor and first floor, and this is second floor. Likewise this stands many more. I cannot put here everything just for purpose, and so many drawings are here. I can't show that drawing also because it's in drawing format, and this is not drawing format, it's PDF. And also you can see this, and we have to go for this purposefully. And there's also structural arrangements. Just a few pieces I have put in. That's foundation plan. So maybe you may not visualize what I'm showing. It's very different plan. My thought of foundations where integrity of building is involved, or you can say where uniform distribution of load is involved, or where horizontal seismic forces are involved, horizontal seismic shear, that I use different method. It's neither raft, it's not piling, it's not isolated footings or independent footings. It's not all that, it's something different. And that point you have to understand very clearly. I'm talking of, it's not simply talking of, but it's giving you evidence that I worked on these foundations, and this foundation is very successful. It's not because there's a technical, but I simply think of, if you use brick walls and construct building, we assume that this is also brick, so it can't go anywhere. But important is here this portion of rectangle. This portion rectangle is a soil improvement, because this strata is having clay up to say 8-9 meters down. We cannot transfer such load to clay, means it's risky. So you have to replace certain portion of foundation to change clay or replace clay by granular material. Granular material, usually a material that is used in water-bound mechanism roads structure, a kind of same material of a different ratio and different requirements. And on this RCC beam has to rest. This RCC beam, which moves around all area of and connecting column to column, and in fact there is no footing of conventional style. This beam connection itself is footing. It's kind of both ways, x and y axis. It moves in same section. So hold this beam that's now in ordinary loading, but when there is horizontal shear impact, this changes its function and resist seismic shears. And same way, here is something different, you can see. Also this is different, various sketches are there, only few sketches I am showing. And in fact this is foundation and this is excavation. Let's see, this is foundation beams here, all foundation beams, and it is excavation scope, and that is where you can say only. And this is important, it takes time to understand, it takes time to, you can say, you see foundation plan, particular area you have to excavate fully, and that's what I can say now. I'm just first trying to show sketches, and that's very important point, then we can discuss. Let me go to discuss first about this purpose of these documents, we can say. What is purpose here, and we have to see what purpose here, why did I do that. I will just read first and then we'll discuss on that. What is that about? And it is still, you can say, it's still very important here. And okay, my percentage is by 3%, 52. Now, we says purpose of this method statement. Actually, it's a method statement, let us say method statement, because we have to understand what we have to do. That is first requirement in construction. Means what we are going to do, why we are going to do, what's background of that, all we have to know. It's not even enough what we are going to do. We are going to do something. Why? From where records are, what was originally recorded, what we are doing, and that which I understand means it's not simply isolation work, just complete package work. You must refer to all records, all documents, and that's the purpose of this method statement, is to describe in brief procedures that were adopted for one house construction long back, and this construction was done in 2008, 2009, 2010, or you can say in beginning of 2009, mid of 2010, about 1.5 years, ordinary construction, but this is time consuming because of many reasons. A synopsis of engineering construction provides the brief details later. Now basement was scoping, this is a basement, ground floor, first floor, second floor, penthouse, etc. all RCC structures from basement, all RCC structures, you can say, all you can say RCC structure from basement to penthouse, including RCC basement walls and walls in bricks at all levels, not in foundations. That walls of bricks also, that is half brick for purpose of filling in, and that exists on every floor except in basement. Doors, windows, aluminium, that is in new work, old work of timber. I didn't like timber, so we did aluminium windows. First we tried plastics, but they didn't work. There was no such expert in plastics to give profiled doors and windows. So we just opted for aluminium, which is also, you can say, has no problems like timber poses, wooden door poses. You can say like that. There are two structures in this. One is existing single story structure, which is about 80 square meters, and other one is extendable hall with first and second floor also. So what was there? Safety, the access ramp for excavation, you can say access ramp was profiled for access to foundation pit, used by personnel and donkeys, workers both. A scaffolding was procured in form of pipes at that time, not structural scaffolding, a couplock system we have these days. The scaffolding was just in vertical use pipes, separate pipes, so no problem, it was braced in. And scaffolding was procured in from pipes as well as wooden batter bellies. Bellies not for purpose of structural use, just for purpose of access use outside. For instance, we need some support. I did not use bellies for vertical propping, no, it's only steel jacking. And then PPs were used to requirements. Timber railing was used on sites, for instance, for safety issues that I'm just giving to you. So reference all drawings and specifications, general, international, and national. And then there's a column of materials, column log of materials. It's a local materials used for all activities. Structural materials were procured from quarries. Reinforcing bars procured in full length at 12 and 14 meters without having any bent bars from industrial site or from factory. All reinforcing bars were fabricated on site only under direct supervision. Concrete was mixed on site since RMC was not consistent in quality. Formwork was designed using plywood and wooden battens, both hardwood and softwood. Here's some history, laughing history, you can say. This was for reinforcing. I thought people are happy to work. I wanted to give it direct contract to some, factory, some fabrication shop, or you can say reinforcing steel fixers. I had only one question to them. I was interested to give my job to them, but I just said that how shall you protect reinforcement? And that gentleman, that worker, had no answer and just laughed at my question. I asked again, can you protect this by material from moisture, from rain? And this person laughed and said, how we are talking about, you just keep as it is, you can see, and all material was rusted lying here and there. No care was taken for that material. So I didn't want to give, if you can protect material, I can give you this work. You fabricate, you cut here or somewhere else, it doesn't matter, but whatever you do should be according to quality requirement. So this they don't realize with them. Same thing happened with RMC. I wanted to use RMC, but when I talked to some RMC guy, he did not have any standard quality systems. They did not have, and I just say, no, this is this cost and that cost. If I raise questions about cement, about what metals they were using, that person had got no clue, no answer. So I said, there's no meaning. I can't trust you. You want to say more quantity of cement will give. And they think only cement is more important, nothing else. Will give you more quantity of cement, so many kilograms of cement will give. I said, thank you very much, I can't understand you. And also these bars, we can say 12 or 40 meters bars. I said no to agency for bent bars. We have to procure only straight bars. We have to pay for trailers if you can't pay. And I did not get any any bent steel. I'm dead against that, and all buildings say 95 to 98% buildings use rusted bars, bent bars, which are straightened first. You see, beauty is first you bend and you straighten them. So what you call it? I don't understand any logic behind that. And whatever formwork we used our own system, our own fabrics, ply, our own designs of that, particularly in columns and slab. Because we casted column one time, 3 meters column or 3.5 meters column or whatever it was. It was casted full height one time. Method statements are very, very simple. Sometimes if you know what you have to do, if you know sequence, you can, then if you know what you have to do, it's only a kind of format filling. So you are not going to do any research work, because research is already, it's available, and what you learned, so that's also a kind of research. So we have to be very careful about, and in fact, for this building, we did not have any light to start it. But this is a small plot, and stones are clear, and you can see you have to so you can see that setting out was done by old method of formation of triangle, right angle triangle, which is 3 base 4 height, or you can say 3 is base and 4 is, you can say, plumb or right angle. Then if you join both corners vertically and horizontally, you get a diagonal. Diagonal is important here for purpose of right angle formation, and that is 3, 4 and 5. Just 3, 4 and 5, what's meaning of that right angle triangle. I'm sorry. Generally, if you don't have a theodolite instrument on site, it doesn't, we cannot work. If we can establish 3, 4, 5 system on site with right angles, there should be no problem at all. Just like we use water level. Just like we use water level purpose of leveling, we cannot use level all the time, and sometimes we have level, sometimes we don't have, but doesn't mean that we cannot work. We can work with equal accuracy by water level. And same way here, I can say we can work with 3, 4, 5 method of thread. If you don't have theodolite, that we have to understand that actually talking is primitive, but fundamentally what it is. So 3, 4, 5 methods, and that's what we use. All references regarding grids and levels were established on existing walls around an area. So this is very primitive. I say surveys. We will survey ourselves, and that's a big problem. in that case you can say method we have defined now. We have to go to start the method, So, now it's excavation, very simple. It's that I just read existing soil type. This battery is 41% remaining. Existing soil type is silty clay per experience, per observation, with sandy state, of course, at 10 meters depth, 30 feet down. No dewatering required since water table is much below, but capillary water may be present. Excavator is so known trade name JCB, generally its name, it may be different company also, was utilized for excavation, mass excavation, and that was limited to some depth because we could not go further due to surrounding buildings which can be impacted upon. So only limited excavation was done using machine, and remaining was done by our carpenters. Other people, those machine people who could excavate 3 meters and then leave it. This means no dewatering was required, and JCB was required for excavation up to limited depth and limited setting out. Reason being that 3 sides buildings existed which did not permit full excavation by machine, because once you excavate, strata is disturbed, and you haven't decided yet what you have to do. This means 3 sides were occupied. You have to take care these should not collapse. Donkeys were used for remaining portion of excavation that could not reach by excavator. Excavated material was removed from site immediately as and when it was dropped into truck or onto tractor. Excavation sites were protected by covering with polythene sheet so that rainwater does not help loosen strength in this case. Blinding is very common term these days, but not in our country. We had different terminology. My God, something plastic again for me. Since soil bearing capacity is not safe to allow heavy structures of this sort, soil improvement was conducted by formation of an improved layer 300 mm deep as explained later. You see what's happening, gastric again, This layer of 300 mm deep is very important here. They are composed of aggregate and coarse dust, duly watered and compacted so that it should also function as a coarse graded strata. On this layer, an application of tape plate coating was carried out, applied for concrete protection. Okay, just a minute. I put my battery on. I forgot, otherwise it will become a big problem that time. I forget it talking and to switch off computer automatically. Oh my God! I'm sorry, my voice is coming off drastic here. To you, you may not feel pleased with that, but what to do? This layer composed of aggregate and coarse, thus duly watered and compacted, so that it should also function as a coarse graded strata, or you can say a kind of filter strata through which water may move in a laminar form or in seepage form, whatever form you can say. And it should not, water should not bring with it, or even if it brings some chemicals, some sulfates or some chlorides, it should not impact concrete. It should pass through this strata, and also you can say the question of some termites, this should also not be impacted upon because of clay is not available. Clay has got no contact with RCC foundations works, and that's a very important point. Maybe it's experience that tells all this. Now on this layer we had to apply waterproofing, chemical waterproofing, this chemical layer to apply on this, and that was the deal in this layer, and application of tape-grade coating was carried out for concrete protection. Coatings of tape-grade was covered with the plaster script for protection. This is just for that, okay. Preparation of blinding was affected, and blinding concrete led to whole area. Blinding was cured for requirement of 3 days, and that's usually done. And blinding is nothing but it is kind of, people call it lean concrete our country. Let us say it's lean concrete, but for me it's not lean, it's not less than 20. Can't be lean also. So foundations, now what we are saying, as we discussed, they are on sketch, on drawings before. And that is their foundation it is. And setting out foundation raft, a part of foundation beam was affected. Setting out means it's just ordinary squaring. Actually, I had good mason or supervisors who knew how to do thread surveying, and using thread surveying, we did all these perpendiculars without no to the light. We had no other equipment, so we used ordinarily string method. And that was useful, of course, very accurate. It's very, very accurate. And preparation of raft, that is including placing fabricated reinforcement. Preparation of raft is including placing fabricated reinforcement, fixing of forms, sides of proposed raft, fixing spaces, cleaning whole RCC space. That's what I'm calling raft. Actually, it's not raft, it's beams, beams bottom. Spreader. The beam bottom spreader, this is. For me, in this case, there was an issue because we had to do RCC tank also. And this tank means I used space between beam foundations, with two foundations, that space for water filling rather than sand filling. Special waterproofing, you can say, in this case, as I said, preparation of raft or raft beams, you may say, or beam frame, you may say, fixing spacers and cleaning whole RCC space. Special waterproofing compound was procured to be mixed with concrete for areas where a water tank portion was included with its raft itself. Concrete mixing and pouring was carried out in one day successfully, followed by application of wooden finish and curing for required number of days. Wooden finish means it's not suspicious, it's just ordinary wood, so that it's roughened, it's not very smooth, no steel toweling on that is allowed. And that's called ordinary because we had to use it later on for bonding purpose. So roughening is for bonding. Actually, this you can say it's given classification of surface finishes according to some specifications, and that's okay. Just like we may call it different types of names, different names you can use, but it's roughening of concrete. Then we had to do foundations. Work started up for upright part of foundation beam, and this is what we say is raft. Means we did also this damper, or you may call it spreader, also along the butt, but in the portion where you can say tank wall, tank beams were involved, it was integrated casting. Integrated means casting a rough portion and beam itself, beam around tank. This is work started for upright portion of foundation beam. All included activities are respecting forms, fixed rebars, fixed box outs, inserts for services, water tank, slab, etc. were prepared. Concrete was mixed for this pour. Concrete was mixed for this pour to be mixed with self-leveling concrete compound. And during this pour, one sectional beam side tried to open, but maturity was controlled. Curing was effective for required number of days. This is just brief on these beam foundation walls. Only brief because it's a different type of work. Actually, it's not conventionally people follow it. It's completely structural design based work, and therefore little different. You can say beams are not very common in foundations, but I standardize it and I can say it's very useful. There's reason for that. If you use isolated footings or independent footings, you won't get that much resistance as you can do in this case of beams. If I use isolated footings, in that case too, I have to use certain compound footings if required. And if not, then I have to use ordinary footings, center footing, but we have to do cantilever calculation on that. And when you say cantilever calculation, means expensive one. But in this case, when all are combined together, cantilever doesn't mean anything. If there's some meaning of cantilever, that's only for spreader. Just 20 and 20 both ways. It's 20 to one foundation is here, then there's 200 mm this went that way. That's not going to work in this case. You can then what to do with that? We can say basement walls and columns we did, and it's also a very important one. Basement columns and walls, and you can say work of RCC walls for basement started immediately after beams were completed. Work of staircase also started in parallel from basement level to its first handling. Work of RCC wall for basement start immediately after beams are completed. Work of staircase also start in parallel from basement level to its first landing. So both were started. Both. I'm sorry, I have to do a gastric problem today. So setting of staircase was given on site using details from AutoCAD so that no error should result on site by contractor, and that's the beauty of this. Means I had to do staircase, how to do it, if you explain to, on you just give you section and so you do it, it's difficult for them. It takes a lot of time and calculations, the calculations that can't be accurate because you have to get exact dimension of shutters and not for concrete. That's the important point. Shutters sketch is required, section, cross section of shutters, cross section of staircase, means how to, okay, drawing is fine, but how to do it on site is another way. It's not only inter-services coordination, but also interdisciplinary coordinations. It's really very, very difficult to get into knowing this. And then you can say setting out of staircase was given on site using details from AutoCAD that no error should result on site by contractor, and then we give details from contractor file, contracting, AutoCAD file. You can say corner to corner, horizontal, vertically, whatever it is. It suits, it applies successfully. And that should be known when you make sites. Alright, now I say, interestingly, basement walls were required to be poured in stages due to the fact that formwork for two walls was only fabricated. Works of columns in parallel, walls and columns in parallel, we did walls separately in columns. So work of columns in parallel commenced as it was to be part of RCC walls. Work of columns can include formwork fabrication, rebar fabrication, and provision of electrical inserts, if any. Setting out for walls, well walls, you can say, lift well walls, and setting out. It's 5 o'clock. We have gone, how much we have gone? 1 hour 19 minutes only. So we can say work of columns in parallel commenced as it was to be learned part of RCC wall. Work of columns included formwork fabrication, rebar fabrication, and you can say provision of electrical inserts. Setting out for walls and columns was given and verified. One by one, all elements were prepared and poured, followed by required number of curing applications. Now it's only a few lines I give to you. Problem is we have to understand coordination. I sometimes I give to you my own writing for coordination, and you are somewhere on some work, you can say, somewhere there in our understanding, and it is really interesting to read that. Now, and also for benefit of everybody, how it is done. Before going further, I will like to add from that. It's in book form, that it's important one. At that age I wrote, and still it works, I think. Still it works. Still it works, and that is beauty of that. It's not because I have to tell you what is that, but because it's very important one. I can start. It is coordination issue. It's coordination issue. That's the important one. How do that? Because it is issue of you can say contracting. We're talking of certain coordinations. This coordination, I guess sometimes it's difficult to remember what I talked to you. I was talking about discipline coordinations, right? Yes, I got something here. Let us see. Structural plumbing and drainage we talked of, and we talked of external services, external works, is it? We talked about structure, right? We talked of this. Let me read again because it's difficult to sometimes remember. I'm talking about something that is, you can say, structural plumbing and drainage. I will read it, you listen to that one, and then we can discuss it later on. What we read here is important and it's really very interesting. From every viewpoint, you can say. From every viewpoint. It's interesting, it should be interesting one. And reading is also important here, you may say. Now what it says is, I'm talking about structural plumbing and drainage. That is what it is, structural plumbing and drainage. Now it says this is a common coordination. This is a common coordination and well known to every civil engineer, and that structural plumbing and drainage is very common coordination and is well known to every civil engineer working on building projects in industry, construction industry, I should say. Adjustment of levels to structure. Adjustment of levels to structure and in foundations, routing of water pipes through walls and floors. Naturally, drainage pipes at ground floor level are concealed underground, and invert levels dictate depth of footing at certain positions. Passage of a drainage pipe through footing and step beam should be avoided and is not generally admissible. And same can pass beneath base level of footing. Sometimes it's necessary to take pipe through structure, in which case structural engineer should be consulted for that particular case, and if required extra provision be made for re-strengthening, or you can say controlling loss of strength, re-strengthening, reduce section above ground floor level. Sanitary pipes generally pass below slab, soffits, and sometimes below beams as well. In every modern building, what we're talking about below ground. Now we are above ground. and below ground we just have certain conditions. We have to avoid passage of these pipes through beams or through whatever else foundations, and above ground generally you can say these are insert actually. These are fittings in above ground construction, and it's go below slab. So it says that it's necessary to take pipe through structure. In that case, structural engineer must be consulted if there's some problem as such, and extra provisions be provided for restructuring or re-strengthening reached section or reduced section, if any, whatsoever above ground. If you consider low level sanitary pipes should generally pass below slab or suspended slope soffits, and sometimes below beams as well. In modern building, suspended falsings are provided, of course, and that's for the purpose. Whenever we say that is purpose, sole purpose, and we can say in this case, false ceiling is provided, falsing is provided, and enough space can be found to accommodate, sanitary pipes, and in which case care should be taken that proposed space for air conditioning or HVAC, ducts, false ceiling, hanging wires, false ceiling short fire used in soft firing by wires, which short fire these wires for purpose of ceiling, false ceiling hanging wires, and electrical cables or trunkings. You can say these cables run on trunkings, they are fixed on within ceilings on sides, so cable trunking and trays, etc. not encroached upon, for which a closed intensive coordination of affected to slab coordination, you can say coordination of the affected zone is required. Only additional cost to be borne is cost of providing steel brackets anchored to slab and pipes resting on brackets. In fact, internal drainage and water supply is a complicated operation requiring high degree of engineering skills and patience. Approach of consulting architect is to see that approach of consulting architect is to see that water pipes concealed in walls, structures, or in finished elements, specifications, or you can say finished elements, and embedded in flooring, for which due care must be exercised to maintain technical general specification of related public works, which shall be necessary for obtaining if required clearance for suppliers. In this field, sanitary works should be dealt with by an experienced foreman or engineer, as chances of mistakes are high in case they are not employed. Material submittals should be done carefully according to program. You can say schedule, program schedule, and that's an important point, and that's what I'm talking of design instruction of these sections. And you can say like this I'm speaking is in relevance to what you can see on this screen. It's just an explanation of that. Let's just say that approach of consulting is okay. Now this is now I say that suppliers in field should be dealt with by an experienced foreman or engineer as clearance, as chances of mistakes are high Some materials should be done carefully according to program schedule. Here we meet program schedule, and you get from that we can say I have to place this material. Now it's time, whatever time we consider before use of that material, consumption of that material, you can say inclusion of that material site, how many months you must have for processing everything. That material capability, said, therefore you can say methods, some materials should be done carefully according to program schedule. Should item misordered, you can say if item is misordered, that's another point we can say it's very important. If item is misordered, you can say delivered and even installed test results shall reveal worthiness, and replacement shall jeopardize price contractor and working of system. So sanitary and planning should be rated a special element in civil engineering construction for building projects. This was only building, and this file showing to you is about building. So we can see that. We can just read and listen to what I'm saying. So it's clear to you in the descriptions, the real descriptions. So you can say drainage contribution, drainage coordination is equally important, since part work is preceded by structural progress. Site supervisor, former engineer shall take care of activities and inspections. I say, drainage coordination is equally important. It is drainage coordination is equally important, since part work is preceded structural progress. Structural part was preceded structural progress. Site foreman engineer shall take care of office activities and inspections to be done at right time to avoid delay in construction activities. Providing block nuts of cubicle seats and units at time. Avoid delay in construction activities, providing blockouts of cubicle seats and units at time of action of formworks. Maintaining top level of traps, flush or 5 mm below, you can say. Below finished floor at location area. Test should be carried out promptly and approval obtained in time. Now this is about drainage, which is important one. Can say again I read. It's important for reference. Drainage coordination is equally important, significant, in fact not very important, because of this system to work. So drainage coordination is equally important because, or you can say, since part work is preceded and you can say structural progress have to follow before that. Structure is done, you have to finish that insert, and that's what stating. Site foreman or engineer shall take care of actions, take care of activities and inspections to be done at the right time to avoid delay in construction activities. Providing blockouts, you can say providing blockouts of cubicle seats and units at time of erection or installation of formwork maintaining top level of traps flush or 5 mm below finished floor level at location area. Test should be conducted or carried out promptly and approval obtained in time. Also find that a line more that test should be conducted promptly and approval obtained in time, and it's for this pending blockouts, maintaining top level of traps flush or 5 mm below finished floor at location area. Test should be conducted daily, promptly and approval obtained in time. This is one part of that, talking is very important one. You have to really, other one is services and finishes. Service and finishes. It's also very, very important point. Service and finishes not easy one, very difficult one. It requires accuracy, and of course that's the important point here. Doesn't understand what it says. I get rid of this. And before that, I have to find something if I can get in coordination, services coordination. Let me see if I can do something building services coordination. If you can get something here, and it's a very important point that. Building services coordination, trying to search out is that is very important point. Building service coordination involves assigning horizontal vertical locations for individual systems. It says building services coordination involves assigning horizontal and vertical locations for individual systems components within defined architectural and structural cost constraints. I can show you certain, let me see what I can show you. I'm sorry. I'm getting a problem with today. Just certain photographs I like to show. These are MVP coordination, everything you need, and then MVP coordination, everything you need. Okay, this is that one. So MVP coordination, everything you need. Let's see what's that. And let's you can say something. I will show you that view. I want to save it just in the file. It's MVP coordination sketch. It says introduction of MVP coordination. I'm just reading. If you do, I'll take print of that, no problem. If you think this is a big one or small one, it doesn't matter. But let's see what's first of all, and this is better. If you're building design philosophy is first time right, what says design philosophy first time right. Let me see better is I think if you're building design philosophy is first time right work. Firmly believe in prevention is better than cure, and that's true. You will try, you truly appreciate value that BIM based MVP coordination, or even if there's no BIM sign of MVP coordination, also known as design collaboration process, brings to a design and construction phase. And you may say that if you appreciate value of BIM coordination, based coordination, also known as design collaboration process, brings to design and construction project. This article of goal is to walk you through entire MVP coordination and share a downloadable checklist, design coordination and drawing review, and download infographic construction workflow. Before we get into MEP coordination, let's understand design phases, building design approach, and building services. And let's see. Says don't have time to read whole blog right now. No worries. Let's send you copies so that this happens. Now, it's building design phases. American Institute of Architects Pittsburgh in their community article has separated building design process into multiple phases. We outlined 5 phases and including emphasis of each phase. And that's here pre-design, and that's emphasis on analysis, outlining goals, and schematic design, emphasis on design, then design development, emphasis on design making. Construction document here, design development. First is pre-design, then schematic design, then design development, and construction document and construction. You all know that. Schematic design, pre-design, schematic design, then development, design development, and called construction document, construction. There's 5 steps. Now, what is traditional approach? Let me see how many pages are there so that you can also see that. Let me take better. It is, I'll show you, and that is what's that? Print. Take print now, so you can see that yourself. It's just reference only for knowing. Everybody know what we're doing. So coordination. I'm trying to coordinate with informations as well. I'll just read it for you again. Now to go ahead, MEP coordination file is here, and we can blow it up a little. You can see this file here for you, and I do this as MEP coordination. We can see, you have to see this. You can see this drawing. This is definition, process, importance, use of BIM benefits, approaches, etc., etc. I'm not inclined. You can see various services here, and what we say is the introduction of MEP coordination. Coordination design philosophy, so we have to design coordinate drawing, etc., etc. It's given there. Now what's MEP coordination have to do with this, and this is really don't have time to read whole big block right document now. There's no worry at all. Let's send you a copy so as you can read it as and it's convenient for you. Just let us know and be our biggest design phases. American Institute of Architects, Pittsburgh, and that has separated building designs to 5 1. That is, one is pre-design, other is schematic design, pre-design, schematic design, design development, construction document, and construction. So it's now what is approaches for design coordination of a construction project? Traditional approach. I'm just trying to save it somewhere so you can read it. You can read it. Right. For many centuries, we can say, basis of architecture projects were 2D drawings, plan sections drawings, those elements. It is hard to find out interference. For many centuries, basis of architecture projects were 2D drawings, plan section elevations, and in those drawings, it was hard to find out interference. Traditionally, MEP coordination is conducted through a sequential comparison overlay process. In this process, functional design is prepared by consulting engineer, while detailed design for each trade is developed by specialty contractor. Specialty contractors sequentially compare their shops drawing of same of you can say same scale in a light table and try to identify potential conflicts. Obviously, this manual method is costly, time consuming, and inefficient. Miss that. We have to now concentrate on this. It's very important. Let me go to files first of all. It says, let's use something important, but let me see, otherwise we will. If it's copyright and I'll close it, let me see what it says. Term policies, copyright mode on MBM. Reference, there's no problem at all, I think. So we have to go back to this. This time to give you more information as possible. So that is in design phases we discussed, and there is now approach for design coordination construction was traditional approach. That was said that which was said for many centuries, which is two triangles and two triangles with no problem ever see. So that CAD was introduced, the designs are made 2D only, we know that all, even this, and we know that it's important when CAD was used. CAD was introduced, designs were made in 2D model, and in this method there is no automated system to identify clashes, conflicts in MP system, and therefore there is a high degree of reliance on such intuition, imagination, technical knowledge, and experience of team members to put out service without site team experience. I don't think that's a true sentence actually. We can do better without software also. 2D drawing can show layout of it, but cannot detect conflict. We can detect, that's no problem. We just concentrate on trying, you'll find all results automatically from code. Okay, so we move forward. Little gap was there because of some reason. So it says when CAD was introduced, designs were made 2D. Now it's not that exactly. And really, it's very interesting about this. To know about this, we can say. I also have the file here. I can say we can do a little more on this. There is, we are not interested in conflicts at this moment. We're interested in what to do, how to do. I'm not interested in 3D modeling also. It says with respect to MEP coordination, traditional design process relies on completed design from all project participation. With respect to MEP coordination, traditional design process relies on completed design from all project participants, that is trades, discipline. While in BIM-based approach, it starts as only now. It says usually MVP BIM model, I'm not interested in this. See, this is unnecessary. I'll remove this if it's that one. Now we are just seeing what stages are there. In fact, it is architectural design, traditional design processes, architectural design, structural design, MEP design, interior design, jack construction, and BM based design is MEP design, interior design, architecture, other construction. I'll just leave it on this. It's all practical, non-practical. I don't think it's very constructive here. Let's go to now architectural, structural, civil, landscape, mechanical, electrical, plumbing, kitchen specific elevators, all this we know. It's no problem here. If it's advertisement, I don't care for that in that case. MEP coordination, everything you know about is still that, but actually what happens is that take this here, design development, before that is pre-design, scientific, this scientific design, develop design, I'm sorry, schematic, not scientific, scientific. So we all discussed about this construction workflow, and that's not big issue. About building design systems, it is architectural system, structural system, building systems, and that we know structural building service, HVAC, electrical, plumbing, vertical transportation says building services, HVAC, electrical, plumbing, vertical transportation, life safety systems and structural systems, elements providing static equilibrium against gravity and dynamic loads, and that's what it says. We have interior system, occupied space encompassing partitions, finished lights, acoustics and furniture, and site service, a landscape and support system for building and including parking areas. Building service system is safety active building systems including mechanical, electrical and plumbing. MEP usually called systems building services must fit in within the constraints of architecture and structure and must meet expected performance regarding comfort and safety. Building systems moderate building environments, distribute electrical energy, allow communication, enable critical and formal manufacturing process, and provide water and disposal of waste, and all scope of building services. System is continually increasing due to increasing requirements of building users. Building projects now include more than traditional mechanical, electrical, plumbing. Such includes fire protection controls, process piping, and telephone, datacom, etc. And now we have here MEP FPS coordination is a practice of multidisciplinary collaboration of three major design verticals of any building infrastructure, which are architectural, structural, beams, column, torsion, and MEP designs. Active systems of building, namely and mechanical, electrical, plumbing, and fire safety frameworks are fundamental components of whatever building. They have been estimated to cost up 60% of total cost of building price as per us. Okay. Mechanical, electrical, and plumbing coordination is one critical. Mechanical, electrical, and plumbing is one critical. Now, active system, you say What are designs actually? Active systems of building can be mechanical, electrical, plumbing, and fire safety frameworks are fundamental components of whatever building. We have been estimated to cost up to 60% total cost of building projects. Mechanical, electrical, plumbing coordination is one critical activity and an important part of constructability review process. Three knowledge domains are required for MVP coordination, namely design, construction, operation, maintenance. Design, construction, operation, maintenance, and trades of can say what are trades can say mechanical systems HVAC equipment, distribution such as cooling tower, air handling units, ducting, etc. Electrical systems, panels, switchboards, elevator, transformer, cable trays, plumbing and sanitary system, pumps, water holding tanks, pool filtration equipment, sump, sewage pit, pump, sewage pit, graves and sand traps. And this is plumbing and sanitary. Fire systems of fire sprinkler pumps, sprinkler tanks, fire shutters, smoke curtains, fire safety tanks, fire sprinklers, pumps, sprinkler tanks, fire shutters, smoke curtains, piping system out of the outside buildings, external works, rooftop, and external faces of building. MVP coordination is all about detecting and resolving clashes among trades. That's MVP coordination. What's that? It's say all about detecting and resolving clashes among trades, architectural, structural, mechanical, electrical, plumbing, and fire safety before construction starts. To keep harmony between these separate designs, it's essential to have a coordination of updated designs of each discipline. Each discipline must be precisely aware of locations of other installations during modeling phases, and this can only happen when latest, most precise version of master plan is made available. It may happen that these designs have collisions or clash in some locations, but one of many components are occupying same space. It's very crucial to get knowledge of these clashes at an earlier stage of construction. Yes. Now, web coordination, as we say, is all about dissecting and resolving clashes among trades, architectural, structural, mechanical, electrical, plumbing, and fire safety before construction starts. To keep harmony between these separate designs, it's essential to have a coordination of updated designs of each discipline. Each discipline must be precisely aware of locations of other installations during modeling phases, and this can only happen when latest, most precise version of MEP's master plan is made available. It may happen that these designs have collisions, clash in some locations where one or many components are occupying same space. It's very crucial to get into knowledge of these drawings at earlier stage of construction project. So what we do is a very important point here, just held, because you can read that also. We said keep it harmony within these disciplines. Each discipline must be precisely aware of locations of others, and that's what we have to do. And these collisions must go. It's very crucial to get knowledge of these the clashes at earlier stage of construction project, which can cost you millions if not detected. Now this BIM, but I'm not interested to discuss what is can you know about that, and that's I'm not going to work on this. I don't have any idea, good idea of this fundamentally, you can say. Now here is the clash report of plumbing too. Name is clash report 274. It is here. This clash report for plumbing too. There's another clash report here. It says the description of hard steel is new clash point is item number this right range plans. Report. Likewise, you can get reports there. Coordinator model with design clashes. Mechanical to plumbing, electrical to mechanical, plumbing to structural, top 10 causes of clashes, found with design coordinations. This is here. I should close this file. That's not as much as expected. Go back to other one. Let's say MVP coordination. I close this one. Let me see what else is there. So this I close and I take other one here. This is MVP coordination, services coordination from again building services. Coordination can be defined as process of management. Let me see what says emerald.com. It is emerald.com. It is saying it's not as HTML, no problem. Let me see if it is also improving building services coordination at pre-installation stage. The purpose is coordinating. Its purpose is coordinating interdependencies between concurrent activities. Special challenge in managing increasingly complex building services projects. Effective coordination of pre-installation stage is key to minimize field conflicts within building services systems. This system aims to investigate significant causes of production shortcomings traceable to pre-installation stage and what extent is then done probably contribute to higher volume of construction debris or findings, and then such limitation originality. It's very small, it's nothing else, I think. It's very small, it's the purpose as a design methodology. Following previous research and studies, finding study reveals that poor coordination among different trades and processes and frequent design changes or errors are seen as two of major causes of production shortcomings in pre-installation stage. Now this paper proposes and discusses improvement strategies based on conceptual models of interdependent teamwork concept, dynamic coordination, buffer and base coordination facilitators. Original values, so I don't think it's anything specific. Let's go somewhere else. And improving building service coordination at display. This is emerald.com. It says now it says so. It's a Wikipedia. What says MP coordination design building. Let me see what says. It's October 21. And MVP coordination design buildings. It says BIM wiki. Oh no, it's BIM again. So let me leave it behind. Listen to that. Engineeringdesign.com also says so you need MVP coordination for a building. Okay, that's fine. Typical stage of MVP coordination building industrial projects. So let's say engineeringdesign.com says, let me see that one. I think I visited this page, so there's no meaning at all. Let me go through this first point. Engineering design says mechanical, electrical, and plumbing coordination services, harmonization of all building services with other disciplines, and that form building fabric, structure, and external steel concrete. Building services include heat, ventilation, air conditioning. MEP team comprises of consultants, MEP contractor, trade specifics, and firefighting subcontractors, fabricators, installation, maintenance specialists. MEP consultants prepare 3D MEP coordinated drawings and pass them to the MEP contractor. MEP contractor is responsible for installations, applications. This means that it's the role of contractor to do detailing, fabrication, spatial coordination, installation of 3D drawings. This is what brings about challenge necessary. So in most cases, MEP consultants' drawings have no clashes. MEP consultant will have to change design to some extent so that they can benefit requirements as far as ease of fabrication, lagging, insulation, allowance, and installation efficiency is concerned. Some changes that contractor is likely to make include duct size, resizing, pipe work, rerouting, splitting out electrical ladders, need for MEP contractor to draw consultants design drawings affect the project deadlines and schedules negatively, which ultimately affects budget. With MEP coordination services, there is increased integration of various MEP team. MEP coordination workers also present 3D environment. Elimination just three-way time, let's say 3 ways MEP coordination services will save your time and money, and that is, you can say, mechanical, electrical, and plumbing coordination services integrate each team's design to address any conflicts during constructability review process, design conflicts, avoid elimination early in process, reduce project work and material dropping offers. And it's also that you can say links are structured. It's just a small page. Let me see. It's very, very small. I don't think there's something great in that. I'll leave it behind. MEP coordination and in buildings and industries. Let's see, there's not much we can say. Blue service, building services coordination, Blue Thorn, and MEP service coordination, design, and all that. No, I don't think something very. I should not be very happy with all this. MEP coordination, hand tech, and all this building consulting. I don't think it's very important. So custom consulting, I'll leave it behind. That's why I say. Let's just about construction. Construction. Let's say construction. Okay. The construction is a general term meaning art and science to form objects, systems, organizations, and come from Latin construction and Old French construction. Constructive work, the act of building and non-construction. So it's also something a little different. Let's say what it says, something you can say process of art or manner of building something. You can say sometimes something building, construction definition meaning a matter of success. Okay. I'm not finding what I expected. Construction Wikipedia versus, let's see. Wikipedia versus, maybe I think it's a good one if you can refer to, or says construction, and let's say construction industry. Construction is a general term meaning art and science to form objects, systems, organizations, and come from construction. Together in structure, the Old French construction. Okay, its most widely used context. Construction covers processes involved in delivering buildings, smart structures, industrial facilities, and associated activities through end of their life. It typically starts with planning, financing, and design, and continues until asset is built and ready to use. Construction also covers repairs and maintenance of works are to expand, extend, improve assets, and its eventual demolition, dismantling, or decommissioning. Construction industry contributes significantly to many countries across domestic product. Global expenditure on construction activities is about okay, so 2012, 4 trillion, total expense, delivered expenses behind history. Okay, construction industry sector, and there are 3 sectors in construction: buildings, infrastructure, industrial. That's buildings, infrastructure, industrial. Building construction is usually further divided into residential, non-residential. Infrastructure, also called heavy civil or heavy engineering, includes large public works, dams, bridges, highways, railways, water and wastewater, including descriptions. Industrial construction includes offshore construction. It's industrial, what I'm saying is offshore construction, mainly of energy installations, mining and quarrying, refineries, chemical process, power generation, mills and manufacturing plants. In industry can also be classified into sector of markets. For example, engineering new records, likewise you can say petroleum, telecom, and building construction is process of adding structures or to areas of land as well as real property sites. Typically, projects instigated by or with the owner of property, maybe an individual organization. Occasionally, land may be compulsorily purchased from owner of public. The residential construction there is, and then you can say non-residential construction there is, and infrastructure construction there is, industrial construction. Industrial construction. Let us say, let me take a print of this just to let you know. We can discuss on this a little. I think it's better to take some print on this so that we can share our opinions. This is a little because it's of course Wikipedia and it's sometimes give better information. It's not bad if you do that. It's a good one if you start say. For you people also to know what we have to do. This is important. We have to search many documents from such, and we have to do that. It's an important one. It's coming. I think it's taking time. No problem. Let's wait about 15 pages. So this can take some time, and we can say Wikipedia, and it's let's again what it says. You can see this page now, and before that I close it. Let me see it also in constructability. We can say MS. It is construction Wikipedia. Okay, construction is fine. It's okay. Save construction Wikipedia. Construction is general topic, says the meaning art and science to form objects, systems, organizations, and comes from Latin. We'll leave it now. In its most widely used context, I just can just blow it a little because I'm not less photos of this. Its most widely used context, construction covers processes involved in delivering buildings, infrastructure, industrial facilities, and associated activities through to end of their life. It typically starts with planning, financing, and design, and continues until asset is built and ready for use. So asset is important here. We can say construction also covers repairs and maintenance works and works to expand, extend, and improve asset and its eventual demolition, dismantling, or decommissioning. Construction industry contributes significantly to many countries' gross domestic products, GDP. All right, that's okay, fine. Although construction industry promotes economic development and brings many non-monetary benefits to maybe many countries, one of the most hazardous industry. So in this we have construction industry sectors: building construction, residential, non-residential, infrastructure construction, industrial construction, the construction process, and that is planning, construction process planning, finance, legal, procurement, traditional and design build, construction, organization, management, design, on-site construction, commissioning and handover, then maintenance and repair, demolition, industrial scale and characters, economic activity, construction GVA by country, carriers, unskilled safety, sustainability, and you have to see that history now. If you take history into consideration, there's a long way to go. So we should construction industry sectors. We talk of this broadly. There are three sectors in construction: buildings, infrastructure, and industrial. So construction in buildings, infrastructure, and structure. Building construction is usually further divided into residential, non-residential, and you can say infrastructure called heavy duty, heavy civil or heavy engineering, includes large public works, dams, bridges, highways, railways, water and wastewater, and distribution. Industrial construction includes offshore construction, mainly of energy installations, mining and quarrying, refineries. This industrial construction is offshore construction, energy installations, mining and quarrying, refineries, chemical processing, power generation, mills and manufacturing plants. And you can say the industry can also be classified as sector of markets. For example, this is, you can say, for example, engineering and news records, saying ENR. As ENR is called, the industry can also be classified as sectors for marketing. For example, engineering new record US-based construction data magazine, okay, has compiled and reported data both sides of design and construction contractors. Okay, in 2014, split data into 9 marketing segments, and these are transportation, petroleum, buildings, power, industrial, water manufacturing, sewer waste, telecom, hazardous waste, and 10th category for other projects. ENR use data on transportation, sewer, hazardous waste, and water to rank firms as heavy contractors. Standard industrial classification, North American industry classification section, classify companies that perform or engage in construction of 3 contractors, subsectors: building construction, heavy and civil engineering construction, and specialty trade contractors. There are also categories for professional services firms: engineering, architecture, surveying, project management. Building construction. Building construction is process of adding structures to areas of lands. Land, also known as real property sites. Typically, a project is instigated by or with owner of property, who may be an individual or whosoever. Residential construction. Residential construction may be undertaken by individual or landowner, self-built, by specialist house builder, by property developer, by general contractor, by provides public or social housing, local authorities, housing associations, where local zoning or planning policies allow mixed-use developments may comprise both a residential and non-residential construction, that may be retail, leisure, offices, buildings, etc. Regional construction practices, technology, and resources must conform to local building authority regulations and codes of practice. Material readily available in the area generally dictate construction material use: bricks versus stone versus timber. Cost of construction and per square meter per square feet. Basis for houses can be dramatically based on site conditions, access routes, local regulations. Economics of scale. Custom designed homes are often more expensive to build, and availability of skilled tradesperson. Non-residential construction. Non-residential construction, depending upon type of building, non-residential construction can be procured by a wide range of private and public organizations, including total local authorities, education and religious bodies, transport undertaking, retailers, hoteliers, property developers, and financial institutions, and other passive companions. Most construction in these sectors is undertaken by general contractors. Then infrastructure contractors. Industrial construction includes offshore construction, mainly of energy installation, oil and gas platforms, wind power, mining and quarrying, refineries, breweries, distilleries, and other processing plants, power stations, mills, warehouses, and factories. Construction process. Some construction projects are small renovations or repair jobs. Some construction projects are small renovations or repair jobs, where owner may act as designer, paymaster, and labor for the entire project. These are renovation or repair jobs. However, more complex or ambitious projects usually require additional multidisciplinary expertise and manpower workforce, so owner may commission one or more specialist business persons to undertake detailed planning, design, construction, and handover of work. Often owners appoint one businessman to oversee project. This may be designer, contractor, construction manager, or other advisor. Such specialists are normally appointed for their expertise on project delivery and help owner define project brief, agree on budget and schedule, lies with the relevant supply chain, comprising subcontractors. Contracts are agreed for delivery of services by all business alongside other detailed plans aimed at ensuring legal, timely, on budget and safe. delivery of specified work. Design, finance, and legal aspects overlap and interrelate. Design must be not only structurally sound and appropriate for use and location, but must also be financially possible to build and legal to use. Financial structure must be adequate to build, design provided for, and must pay amounts so it's an important part. We have to be with this for something. The design, finance, and legal aspects overlap and interrelate. Design must not be structurally sound and appropriate for use and location, but also be financially possible to build and legal to use. Financial structure must be adequate to build, design provided for, must pay amounts that are legally owned. Legal structures integrate design with other activities and enforce financial and other construction processes. This process also affects procurement strategies. Let me example. For example, appoint a business design project after which a computer process is undertaken to appoint a lead contractor to construct asset. They may appoint a business lead both design and construction, or may directly appoint a designer, contractor, and specialists of contractors. Some forms of this process also affects procurement strategies. Clients may, for example, appoint a business designer or this is planning. What is planning? So let's say okay. I'll back of some times. No, it's about I was back. One, 2 hours, 30 minutes. No problem. It's okay. Back in a couple of minutes. Okay, I'll go back for about 15 minutes, 5 minutes, and come back. 5 minutes only, not 15 minutes. I'm sorry to say. It's just 5 minutes. I'll go back. Come back. Sorry, gentlemen, I'm a little late again. It happened. What happens? What can I do? We take this opportunity to do as much as possible. Only that is way. Otherwise, we are all in the same boat. Coordination has no end. Coordination has no end. We know that, and it works everywhere. And that's really very important one. We live for something that we do not know, and we successfully do something that we do not know. Ultimately, we do this, and we can say that when applicable, like in this case, we can say that when applicable, a proposed, you can say when applicable, a proposed construction project must comply with local land use planning, and is for planning, and also this is here for, you may say, it is construction process. Some construction projects are small renovations, you can say. This is very easy. Small but complex and ambitious projects usually requires additional multidisciplinary expertise and manpower workforce. So owner may commission one or more specialist business to undertake that responsibility, and we can say that it happens in this field, in this world. Owner appoints certain designer, contractors, whosoever, likewise, and then you can say design, finance and legal aspects overlap and interrelate. Design must not only structurally be sound and appropriate for use or location, but also be financially possible to build and legal to use. Financial structure must be adequate to build, design provided, and must pay amounts that are legally owed. Legal structures integrate design with other activities and enforce financial and other construction processes. These processes, we can say, these processes also affect procurement strategies. Clients may, for example, appoint a business to design project after which a competitive process is undertaken to appoint a lead contractor that may appoint a business to lead both design and construction, the design build, or they may directly appoint a designer contractor and specialist subcontractors. Some forms of procurement emphasize collaborative relationships, whatever it is. Now this is planning, you can say. When applicable to you, proposed construction project must comply with local land use planning policies, including zoning and building code requirements. A project normally be assessed by authority having jurisdiction, whatsoever it is, that you know all well, where project will be located by authority having jurisdiction, and municipality whatsoever where project will locate, for example, for potential impacts on neighboring properties and upon existing infrastructure, transportation, social infrastructure, utilities, all that data may be gathered together site unless it's surveys, geotechnical investigations. Construction normally cannot start until planning permission has been obtained and may require preparatory works to ensure relevant infrastructure has been upgraded. Now, preparatory works will also include surveys of existing utility lines to avoid damage causing outages and other hazardous situations. Some legal requirements come from malum in sea consideration or desire to prevent indisputably bad phenomenon, namely explosions of bridge collapse. Other legal requirements come from malum prohibition, considering all facts that are matter of customer operations. An attorney may seek to change. All right. Now, during construction of a building, a municipal building inspector usually inspects ongoing works periodically to ensure that construction adheres to approved plans and local building codes are not violated. Once construction is complete, later changes may be made to building or other assets that affect safety, including issues, expansion, structural integrity, and fire protection usually require municipal approval. Finance, depending on type of project, mortgage bankers, accountants, and cost engineers may participate in creating an overall plan for financial management of a construction project. Presence of mortgage banker is highly likely Even in relatively small projects, since owner's equity in property is most obvious center or source of funding for a building project, accountants act to study expected monetary flow over life of project and to monitor payouts throughout processes. Professionals in cost engineers, estimators, and quantity surveys apply expertise to relate work and materials involved in property valuation. Financial planning Financial planning ensures adequate safeguards. It says financial planning ensures adequate safeguard and contingency plans are in place before project is started and ensures a plan is properly executed over life of project. Construction projects can suffer from Preventable financial problems underbids happen with builders ask for too little money to complete project. Cash flow problems exist when present amount of funding cannot cover current costs. Underbids happens when builders ask for too little money to complete project. Cash flow problems exist when present amount of funding cannot cover current costs for labor of workers and materials. Such problems may arise when even overall budget is adequate. Presenting a temporary issue, overruns with government projects have occurred when contractor identified change orders or project changes that increase costs which are not subject to competition from other firms as they have already been eliminated from consideration after the initial bid. And fraud is also an occasional construction issue. Large large projects can involve highly complex financial plans. Large projects can involve highly complex financial plans and often start with a conceptual cost estimate performed by building estimators. As portions of projects are completed, they may be sold, supplanting one lender or owner for another. While logistic requirements of having right trades and materials available for each stage of bidding construction project carry forward, public-private partnership or private financial initiatives may also be used. Now, legal is a construction project is a complex net of construction contracts and other legal obligations, each of which all parties must carefully consider. A contract is the exchange of a set of obligations. A contract is exchange of set of obligations between two or more parties and provides structures to manage issues. For example, construction delays can be costly, so construction contracts set out clear expectations and clear paths to manage delays. Poorly drafted contracts can lead to confusion and costly disputes. At the start of project, legal advisors seek to identify ambiguities and other potential sources of trouble in contract structures. At present, options for preventing problems during projects, they work to avoid and resolve conflicts that arise. In each case, lawyer facilitates an exchange of obligations that matches reality of project. Procurement, traditional or design built building. Design, bid, build is most common and well-established method of construction procurement. Architect, engineer, or builder acts for client as project coordinator, designs, once work is designed, prepared specifications, means work is designed, specifications are prepared, and designs are deliverables, model drawings, etc. administered. Now, who administers contract? That person administers contracts, the engineer, and then work is standard, can say. So, administration of contracts is very important here. Manage works from inception to completion. In parallel, there are direct contractual links between client and main contractor, who in turn has direct contractual relationships with subcontractors. Arrangement continues until project is ready for handover. So you can say it's a kind of a traditional one. So let's see. Now let's design build. Traditional design build. It is a design bid build. So I read again, design bid build is most common and well-established method of construction procurement. This is arrangement architect, engineer, builder acts for client as project coordinator. They design works, prepare specification, design deliverables, and administer contract under the works and manage works from inception to completion. Parallel, there are direct contractual links between client and main contractor, who in turn has direct contractual relationships with subcontracts. Arrangement continues until project is over. Design build. Now, design build. Design build became more common from 20th century and involves client contracting a single entity to provide design and construction. In some cases, design build package can also include finding site, arranging funding, and applying for all necessary statutory consents. Typically, the client invites several D&B contractors to submit proposals to meet project brief and then select a preferred supplier. Often this will be a consortium involving a design firm and a contractor, sometimes more than one of each. In the United States, Departments of Transportation usually uses design build contracts as a way of progressing projects where states lack skills or resources, particularly for very large projects. Now, what is design here? How is design build? Now, design. In industrialized world, construction usually involves its translation of designs into reality. Most commonly, in a design build project, design team is employed in contact with property owner, depending upon type of project. A design team may include architect, civil engineer, mechanical engineer, electrical engineer, structural engineer, fire protection engineer, planning consultants, architectural consultants, and archaeological consultants. A lead designer shall normally be identified to help coordinate different disciplinary inputs to all overall design. This may be aided by integration of previously separate disciplines, often undertaken by separate firms, into multidisciplinary firms with experts from all related fields, or by firms establishing relationships to support design build process. Increasing complexity of construction projects. Increasing complexity of construction project creates a need for design professionals trained in all phases of a project's life cycle and develop an appreciation of asset as an advanced technological system requiring close integration of many subsystems and their individual components, including sustainability for buildings. Building engineering is an emerging discipline that attempts to meet this new challenge, and that is increasing complexity of construction projects creates need for design professionals trained in all phases of project's life cycle and develop an appreciation of asset as an advanced technological system requiring close integration of many subsystems and their individual components, including sustainability. Traditionally, design has involved production of sketches, architectural and engineering drawings, and specifications. Until late 20th century, drawings were largely hand-drafted. And drafted adoption of computer-aided design technologies then improved design productivity, while 21st century introduction of building information modeling process has involved the use of computer-generated models that can be used in their own right to auto-generate code drawings and other visualizations, as well as capturing non-geometric data about building components and systems. On some projects, work on site shall not start until design work is largely complete, and some design work may be undertaken concurrently with early stages of on-site activity. For example, work on a building's foundations may commence while designers are still working on detailed designs of building internal spaces. Some projects may include elements that are designed for off-site construction and are then delivered to site ready for erection, installation, or assembly. On-site construction once contractors and other relevant professionals have been appointed. Once contractors and other relevant professionals have been appointed and designs are sufficiently advanced, work may commence on project site. Work may commence on project sites. Typically, a construction site includes a secure perimeter to restrict unauthorized access, site access control points, office and welfare accommodation, and personnel from main contractor and other firms involved in the theme and storage area for materials, machinery and equipment according to McGraw-Hill, the Dictionary of Architecture, Leavitt, and construction definitions. Construction may be said to have started when first feature of permanent structure has been put in place. Commissioning and handover. Commissioning is process of verifying that all subsystems of a new building work has intended to achieve owner's project requirement and are designed by project architects and engineers, maintenance, repairs and improvement, and the demolition. Industry skill and characteristics we'll discuss on later on. Now we can say we'll go back and see what to do with that. Now I think it's all relevant, but let me save it for purpose of next time discussion, because we'll discuss it. This is also important one, and you can say it's also important one. In fact, this is QPD. I think I've done it already. Yes, that's okay. It already lies there, no problem. So I'll take closer of this file now, and because it's something you can say. As we move onwards, we find this. Now it is about I think 3 hours already gone. No problem. 3 hours in the house. That's not a big problem. Here is construction of house we're talking of, and talking of basements. And we'll continue this also second page only, but we'll talk of this also, which is because it's also important for this. In this file that's regarding this house, and for that purpose I moved away from this, and also certain quality and coordination issues and certification and all that we started here in the South Construction was talking about. We'll take up this issue. It's also very important one, and you can say it's very elementary, but it's very important, as we have given certain records of this, real records of this house foundations, and it's really informative, you can say, very informative, and also we may say that in that way we will go to see how this work in this quality file and this coordination file. So we have something that's wonderful. You can say here, if you I just blow it down and say that, because we have discussed these slides which are very important from every point of view. We have gone through all this to learn something, to revise something, to refresh something, and it's really interesting on in this coordination engineering world. as I'm saying, coordination, though it's nothing to do with BIM, but it's mental state coordination, you can say. Sometimes, it's difficult to work with software in plain works, or where we can say mind can reach and mind can solve problems. And some problems are in isolation that we solve on a particular site. I'm not talking about major design problems, we're talking about site problems. Sometimes we have to resolve problems on site. That can happen, that happens. It's very interesting on sites these problems happen, and we have to take care of that. You can say so many issues on this, and I'll see what can be done, in this case. It's very wonderful to see that we have covered today quality, coordination, engineering projects, and reliable engineers, communication, concrete engineers, etc. etc. We have done this, and I think it's time to close it now. Let me see now. Thank you very much. I say we'll see again.